Assalamualaikum and hi everyone. Our group today, Wonderpet, will represent of replacement algorithm. This is our group members. My name is Ahmad Arif Fahmi bin Zainal with matric number 1200548. Our members is Muhammad Haikal bin Zulmi, Wan Muaz bin Wan Muhammad Nasir, Muhammad Saifuddin bin Nordin, and Hana Wahida binti Elmi Fansuri. Definition of basic algorithm. An algorithm is a procedure used for solving a problem or performing a computation. There are certain basic algorithms that are used for the selection of a page to replace. There are a total of 4 replacement algorithms that we can use for the selection of a page to replace. First, optimal. Second, LRU, which is least recently used. Third one is FIFO, first in, first out. And lastly, clock. Let's move on to the first definition, which is FIFO, first in, first out policy. First in, first out treats page frames allocated to a process as a circular buff. In this algorithm, pages are removed in round-robin style. It also includes simple replacement policy to implement the pages. The page that has been in memory for the longest will be replaced. Let's see how does FIFO exactly works.
I will explain using FIFO method. Page address stream that I choose is number 2321651278225. Okay. So here are the tracking lists. We will start with number 2. We need to insert number 2 on the top of the queue. So in the tracking list, also same, we need to put number 2 on the top. Okay, next is number 3. I need under the number 2. So 2, 3. Okay, in the tracking list, I put number 3 also under the number 2. Okay, it's number 2. Number 2 is already inside in the queue. So it means that there are no replacement. There is no data transfer between hard drive to RAM. So we just write 2 and 3. Okay, next is number 1. I insert on the bottom of the queue, so it becomes 2, 3, 1. Okay, in the tracking list, I put the number 1 as the new start, 3 and 1. Okay, and then next is number 6. Number 6 will replacing number 2, so it will become 6, 3 and 1. 3 and 1 will go up, so the number 6 will I put number 6 on the bottom. Okay, so it becomes 3, 1, 6. And then next is number 5. Number 5 replacing number 3. So it will become 6, 5 and 1. So in the tracking list, number 1 and 6 will go up, 1 and 6. So I put number 5 on the bottom. 5. Okay. This is number 1. Number 1 is already inside in the queue, means there are no replacements. So we just write it again. 6, 5, 1. Okay. And then in the tracking list also same. 1. We follow it. We follow this 1, 6 and 5. Okay. Next, number 2, replacing number 1. So it will become 6, 5, 2. Okay, in the tracking list, 6 and 5 will go up, 6, 5 will go up, and number 2 will put on the bottom. So next is number 7. Number 7 will replacing number 6 become 7, 5, 2. So in the tracking list, number 5 and 2 will go up. 5 and 2 will be number 7 on the bottom. Okay, next is number 8. Number 8 will be replacing number 5. So it become 7, 8, 2. Okay, next in the tracking list, 2. I put number 8 on the bottom. Next is number 2. Number 2 is already inside in the queue, means there are no replacement. So we just write 7, 8, 2. Okay, in the just see 2, 7, and 8. Okay, next is number 5. Number 5 replacing number 2, so it will become 7, 8, and 5. 5 on the bottom. So number 7 and 8 will go off the queue. I need to identify where are the page fault. So here has page fault. So we need to put F. Okay, page fault replacement happen. Okay, so here the replacement happen. So next is this column has page fault. Okay, here are the same, so there are no replacement. So here there has replacement, so we need to put F. Okay, and then this has page fault. So here also has page fault. And the last one here, page fault. So there are 1, 2, 3, 4, 5, 6. There are 6 page fault in this page address string using FIFO method.
Okay, let's move on to definition of optimal policy. The optimal policy selects for the replacement that page for which the time to the next reference is the longest. In this algorithm, it produces 3 page faults after the frame allocation has been filled. It also does serve as a standard against which to judge real-world algorithms. So, let's see how does optimal policy exactly works.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal Muzulmi and my matrix number is 1200539. Okay, now I will explain about optimal algorithm. Okay, optimal algorithm will give chance for pages which will be used again to stay longer. Okay, first thing first, we need to add what page number that we want. Let's say we put 232252453242. Okay. First, 2 need to enter the slot, the first slot of the frame. So then 3 need to enter the available slot, which is below 2. Okay, next, since we have the same page file repeated again, which is 2, so no need to change or add anything, or basically no page fault happen. Okay, this shows that no data required to be transferred from hard drive to computer RAM because required page is already there in the RAM. It just reused the existing page. Okay, then 5 will enter the available slot below 3. Next, 2. Okay, 2 is also already exists in the memory, and we just reuse the same page frame, which is 235. Okay, next, 4 will need to enter, but how? Which page file need to be removed? Okay, first we have to look at the tracking slot here. Okay, at the tracking slot we put 235. So we need to check to where it will be used again. So we have to count how many pages next will be used. So okay, now number 2, we just count until we reach number 2. So let's say 1 2 3 4. So 4 4 3 1 2 3. So 5 only 2. Okay, so 4 need to enter and replace the one that not used, or if all will be used, it will remove the largest count, which is the most far away. So there is no unused. So if all will be used, so we just remove the most far away. So in this case, 2 is the most far away, which is 4. So we just remove 2 and replace it with 4. So the frame will be 4 3 5. Okay, next, number 5 is also already exists in the memory, so we just use the previous frame, which is 4 3 5. So 4 3 5, and then 3 also already exists, so we just no need to change anything, we just copy and paste and use the same memory. And then number 2, okay, number 2 is different. We just we look at the tracking slot here. Okay, look at number 4. We count 4 is 2 and 3. There is no 3 and also there is no 5. So we simply just set it as none. So in this case we have 2 none. So we just use FIFO, which is first in first out. We just remove number 3 with number 2. So the page file and the frame will be 4 2 5. 2 will replace number 3. So okay, next, 4 is also already exist. We just use the same frame, which is 4 2 5, same as the previous frame. So next, the last one is 2 is also already in the memory, so we just use the same page frame, which is 4 2 5. So here we can see that only 2 page faults happen during this optimal algorithm. So I think that's all from me. Assalamualaikum.
Now, let's move on to definition of LRU, least recently used policy. The least recently used policy replaces the page in memory that has not been referenced for the longest time. In this algorithm, the principle of locality, it should be the page least likely to be referenced in the near future. There are 2 reasons why it is difficult to implement. First, one approach is to tag each page with the time for last reference, and the second one, this requires a great deal of overhead. So let's see how does LRU exactly works.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Safri Pinodin with metric number 1200568. In this session, I will explain about how LRU works. LRU will favor pages recently or frequent appearing in the past to stay much longer. First, we need to set our page address stream by any random number that can be either repeated or not. This is number chosen by us, which is 2322524532242. There are 3 slots below page stream indicated for iteration to resemble the execution as time goes forward. First, we insert number 2 in the slot and continue with the second box, which is 3. The number continue with the previous, which is 2, resulting 2 3 in the slot. In the next, the number will not inserted to the slot due to existing number 2 already appear. So the slot will have the same as previous. In the 5th box, we insert the number 5 below 3, making the sequence 2 3 5. Since the next box has the same situation as previous, we don't need to insert any number in the slot. To show how LRU works, we can see from the 7 page stream, where since the number 2 and 5 is more recently than 3, 3 will be removed then replaced with number 4. This caused a page fault because we changed the number from the slot. In the page stream, number 9, 2 will be replaced with number 3, where the slot becomes 3, 4, 5. Next, 4 will be replaced with number 2, the slot becomes 3 to 5. And lastly, 5 will be replaced with number 4, 3 to 4. As a result, there is 4 page fault happen in this LRU session. We can see the F symbol in slot 7, 9, 10, 11. We can see how LRU works, and that's all from me.
Let's move on next to the definition of clock policy. Clock policy, known as the simplest form, where it requires the association of an additional bit with each frame referred to as the use bit. In this algorithm, when a page is first loaded in memory or reference, the use bit for that frame is set to 1. The set of frames considered to be a circular buffer, and any frame with a use bit of 1 is passed over by the algorithm. Clock also can page frames visualized as laid out in a circle. So let's see how does clock exactly works.
Assalamualaikum, my name is Wan Maaz, metric number 1200561. I'm going to explain how does clock algorithm work. Okay, so first, this is our page stream starting with 7 until 9. Okay, so first process, we start with 7, and 7 is the first to get in the space, and this arrow indicate the next page to replace. And after the first empty space have been replaced with 7, and it will be automatically locked, and the arrow will move to the next empty space, and will move to next page. um, According to based on where the arrow is indicate, 5 will replace the will fill in the space where the arrow have been indicate. And then it will also in clock algorithm, when it placed in the space, it will be automatically locked. Next, we'll move to 1. uh, Same with the other, with 7 and 5, it will fill in the empty space. And next, uh, next the arrow will indicate will show on 7, and 9 will replace it. Before that, because all the space is locked, the arrow will find which space is unlocked, so it will begin to move down from 7. Because it locked, it will move down to 5, and 7 will be unlocked. 5 also locked, so it moved to 1, also locked. And 5 and 7 unlocked, it will go back to 7, and because 7 is already unlocked, 9 will replace 7, and it will be automatically locked. Next, 6, because 5 is unlocked, and arrow also indicate there, and 6 will replace 5 and automatically lock. Next, 3 will replace 1, because the arrow indicate on the 1, and also will be automatically locked. Next, 6 here, because in the page we have already have 6 in there, it doesn't make any change, and the arrow also doesn't move. Next, 8. Because same with this one, you will also find the arrow will find which space is unlocked. So it move down and move down from 9 to 6 to 3, and before after the move from 9 to 6, all the number will be unlocked, and the arrow will go back to 9 and 8 will replace 9. Okay, next, 1 will replace 6 and will be automatically locked. Arrow indicate at 3, and 5 will replace 3 and will be automatically locked here. Because it is already in the page, it will doesn't have any changes, and the arrow also doesn't move down. And lastly, 9, the arrow will first same with before, the arrow will move, will find where is the unlocked one, and after it pass the space, the number in the space will be unlocked, and the arrow will move to top again, and 9 will replace 8 and will be automatically locked, and the arrow move down to 1. And that's all for clock algorithm.
So that's all from our group about the explanations of replacement algorithms. Thank you and have a good day.